Okay, hi everyone. So today's what we're going to do is we're going to work on factoring larger order polynomials like we did before. You guys had the real basic way of doing it using synthetic division, figuring out what the possible roots are, and from there using synthetic division to figure out which of these possible roots are roots, and then writing factors from those. Today we're going to kick it up a notch, and we're going to see I'm going to teach you guys how to use synthetic division when there is a value in the front that is not 1. So let's take our first example here, and that's going to be 6. Whoops. It's going to be 6x cubed minus 38x squared plus 26x plus 70. Okay, this we're jumping right off the deep end. This is a huge number. Now, my first skill is to teach you guys how to write the roots. Now, these roots here are going to be special because of this number in the front. So let's talk about how we normally would find roots. We would say, looking at the back term, our possible roots are r is equal to what multiplies to become 70? 1 times, I'll give myself a lot of space, 70. Then another possibility is 2 times 35. And 3 doesn't go here. 4, nope, 5. How to know that 5 works? Well, 70 and 5, yeah. 5. Now, how do I do 5? Is I actually kind of steal it from this. I know there's a 5 times 7 is 35. But of course, 5 and, or you can just straight divide. 5 goes into 7 once, left over 20. So 5 goes into 20 4 times, so that's going to be 14. And we know 7 and 10. Oh my goodness, there are so many possibilities for this problem. And that's the thing about large ordered polynomials. For easy problem, sure, that's easy. And yesterday when you guys did the My Open Math problems, some were easy, some were hard. And the thing is, the hint is this: I'm going to give you, for the most part, not all the whole test, but for a lot of the questions, at least a starting value to guess on. Okay, I'm going to tell you one of the roots. But to start, I'm going to give you guys all the possibilities here. Now, because of this front number here, we have more possibilities. And why is that? Well, let me give you an example off to the side, just on the side here. If I give you 3x plus 2 times x plus 1, this is 3x squared plus 5x plus 2, okay? So if we use our previous rule for finding roots, our r values, looking at the back, would be possibilities 1 and 2, right? 1 times 2. Super easy problem, super easy example. But are all my roots just 1 and 2? Looking here, my root is actually -1 and -2/3, right? Those are the x values that would make this go to 0. But you don't see 2/3, do you? Because here is the second part of our root rule. To find the roots, not only do we break apart the last value, we then divide by the front value, all the possible factors for the front value. So not only do we have 1 and 2, but we also have 1/3 and 2/3. So what you do is you take your initial roots and we divide them by this front value and all the factors of that front value. Now, are our answers buried in this problem? Do our answers show? We said we need a -2/3. Yes, we have a 2/3. We have a -1. We have a 1. And remember, all these answers are plus or minus, plus or minus, plus or minus, plus or minus, because we don't know if it's plus or minus. Okay. So how if this got a little bit more crazy? What if there were 2 numbers? What if I said 2x plus 1 and 3x plus 2? If I multiply these together, we would have ended up with 6x squared, 3, 4 plus 7x plus 2. If I use my root rule from before, the r values are possibly 1 and 2. Okay, those are my possibilities, 1 and 2. How did I get that? Because the factors of 2 are just 1 times 2. Those are my only possible values from the back. But now we have a value in the front. Now what we do is we say we have to divide it all by the possibilities of 6. That's 1 times 6 and 2 times 3. Aren't all these the possibilities for the value 6? Now here's the issue. We don't know which of these would have been the fraction. So we have to write down them all as possibilities. 1/2 2 over 2. Luckily, this is just a repeat. That's 1, right? Then we do 1 over 3, 2 over 3. And then we do 1 over 6, 2 over 6. But luckily for us, that's also just a repeat. So when we have numbers with a different coefficient, it shoots up exponentially all the possible roots that we have. These are possibilities. These aren't actual roots. These are all the possibilities that we could come up with. Oh my goodness, there's so many possibilities. Now, are our answers really here? The answers here are negative 1 over 2. So the roots here, negative 1 over 2. That was a root, yes. That was a possibility. And negative 3 over 2. No, it's not 3 over 2. Negative 2 over 3. Yes, that was also a possibility. Okay. The goal here is to say, hey, what are my possible roots? Okay. We don't have all the numbers in the known universe as possibilities. Only these possibilities. And though there are numerous, there are a lot, at least it's not infinity. And we come up with the possibilities. Now let's go back, after we looked at these examples, to our problem up here. Now, it's going to be a lot of writing. And please bear with me for this. We're going to write them all. So, not only are 1, 2, 5, 7, 10, 14, 35, and 70 possibilities, 1 over, okay, to make 6, that's 1 times 2 times 3 times 6. These are all the possibilities to make 6. 1 over 2, 2 over 2, 5 over 2, 7 over 2, 10 over 2, 14 over 2, 35 over 2, 70 over 2. But please pay attention that a lot of these are repeats. Isn't 2 over 2 just 1? I'm just highlight them so you guys can still see them. Isn't 2 over 2 just 1? Isn't 10 over 2 just 5? Isn't 14 over 2 7? Isn't 70 over 2 35? We have these repeated already. Okay, so really only adding 1, 2, 3, 4 when it comes to 2. But that's not all. We now have to do the next set of numbers. I get it. It seems like a lot, but again, we're just writing out all the possibilities. Writing down all the possibilities. Here we go. Next one is 1 over 3, 2 over 3, 5 over 3, 7 over 3, 10 over 3, 14 over 3, 35 over 3, 70 over 3. See, so we use the 1, we use the 2, we use the 3, like 1 over 1. We don't have to write that. Okay, moving on. Keep going. Kind of terrible, right? All right, one more round. 1 over 6, 2 over 6, 5 over 6, 7 over 6, 10 over 6, 14 over 6, 35 over 6, and 70 over 6. So why are we writing all these possibilities? You know what? These are my only options. I get it. It seems like a lot. But this is a hard problem. This is a hard problem here. Okay. So all these are also plus and minus, right? I only write plus minus for my first number. Just realize, remember, these are all plus and minus. Now, these are all the possible roots. Are they all answers? No, they're not. But these are possibilities. Okay. Now, I'm going to give you a hint now. The root for this problem is going to be 5. The root is equal to 5. So let's use synthetic division and break this number down. 6, negative 38, 26, and 70. Okay, using synthetic division, saving us time. The root we said was 5, so the factor is x minus 5. So be careful here. The factor is x minus 5. So the value is going to be 5, right? We always make it go to 0 for the synthetic division. All right, let's see if 5 works. I told you it should work. It should work. 6, bring down the 6 first one's free on me. That's going to be 30, multiplying up by 5. Remember, we always multiply to go up. 38, negative 38 plus 30 is negative 8. Multiply up, become negative 40. This is negative 14. Multiply up, 5 times 14 is 50 plus 20 is 70. Negative 70. Winner, winner, chicken dinner. All right. Okay, easy peasy. Let's rewrite this problem. is going to be 6x squared minus 8x minus 14. Now, here is the next struggle, and the struggle is real, okay? The struggle is real. The struggle is, how do I factor this? One trick is, you can see here, you can see that there's actually a 6, 8, 14, so we can actually pull out a 2 from everyone. So I can do that. Let's pull out a 2 from everyone. So it's going to be 2 left over 3x squared minus 4x minus 17. Oh, minus 7, I'm sorry. And then we're going to have to factor this. Okay, so how do you factor this? So this is what I call a level 3 factoring problem. You have to come up with all the possibilities and figure it out. Maybe some of you guys already can see it. Now, the way I factor is I say what numbers multiply to become 3 and what numbers multiply to become 7. That's going to be 3 and 1 and 7 and 1. Oh, good. Only one possible choice. Now, which of these combinations would subtract out to become the middle number? Okay, a minus sign means we subtract. So you take a number in the front and you date it with the back. 3 times 7 is 21. So, hey, wingman, thanks for covering me. 1 times 1 is 1. Is 21 minus 1 4? Fail. You suck as a wingman. So we know 3 times 7 doesn't work. How about 3 times 1? 3 times 1 is 3. 1 times 7 is 7. Hey, is 7 minus 3 4? Yep, as long as we have more negatives than positives. So I write my factors out in place. It's going to be 3x and x. Now here is a tricky part. Do I write 7 and 1 or write 1 and 7? Where does it go? Where does it go? So please take a look here. What I do is I draw a little frog face. We talked about this before. And who do you multiply 3 by? You multiply 3 by 1, right? So if this is 1, this is 7. We used up all our numbers. 3 and 1, 7 and 1. Who do we say has to be negative? The 7 has to be negative because 7 times 1. And we need a positive 1 times 3. Okay. So let's write down all of my factors. If I ask you, please factor the following problem. Our original factor was x minus 5. We took out a 2 in the front. And we have left over 3x minus 7 and x plus 1. Oh my gosh, Mr. Go, you're going to war. Wait, did I mess up? Oh yeah, we're good. Okay. Seems like a lot of work. But realize this is a big problem, right? It's like a house is expensive. You have a big house, more money, even more expensive. You have a tiny little shack, cheap, easy. You have an apartment, small, super tiny apartment behind like McDonald's or something, even cheaper. But if you want a big place, you got to do a lot of work. And that's the point here. This is a big problem, so we have a lot of work here. Do you have to write down all these possibilities? Nope, but they are helpful, especially if I have no clue where to start. Now, I want to show you guys that all these answers, my roots are hidden here. To make this go to 0, that would be 5. To make this go to 0, it would be 7 over 3. To make this go to 0, it would be negative 1. Are 5, 7 over 3, and negative 1 possible roots? Let's take a look here. We have 5, 1, and we said, what was the last one? 7 over 3. And 7 over 3 was a hidden root here. Let's use a different color. Right. These were possibilities. So they were in the crowd. Now, I have one more thing to go through. No, I have a couple more things. I want to teach you guys how to divide using synthetic division if my root was a fraction. Okay? So we're going to use the same exact problem because the problem was pretty big already. But if I wrote 6x cubed minus 38x squared plus 26x plus 70. And we're going to use synthetic division to factor out the root 7 over 3. 6, negative 38, 26, and 70, and the root is 7 over 3. Now, this is where synthetic division has issues. There's a hiccup here. There is a hiccup. We know that the factor should be, we said the factor is, looking up here, the factor is 3x minus 7. That's what the factor says. We can see that, okay? But synthetic division does not see that. Synthetic division sees this. It sees x minus 3 over 2, x minus 7 over 3. Now, we'll have to deal with that problem once we're done with synthetic division. So please be aware, if we have a fraction as a root, or if we have a coefficient in what we're trying to divide, if we're trying to divide this guy, you have to realize that synthetic division is broken here, and you can still fix it, but we have to be aware of it. So let's go ahead and do it. Now, you might say, Mr. Ko, how is a fraction going to work? It's going to kind of suck, but not really. Bring down the 6, and here's what we do. We multiply by 7 over 3 to bring it up. Now, you might think 7 over 3 is going to be hard, but it's not. First, what's 6 divided by 3? We always divide our bottom numbers. 6 divided by 3 is 2. 2 times 7 is 14. We just write 14 on top. Okay, let me show you guys that again. I'll write it in big font. 6 times 7 over 3. You can divide that, becomes 2. 2 times 7 is 14. If you want to go the long way, 6 times 7 is 42. Divided by 3 is still 14. But I think dividing is easier, and you can almost always divide it if it's clean. Okay, let's combine it. 38 and 14 subtract out to become 24. Negative 24. Right? We're going to multiply this by 7 over 3. So everyone take a look here. I'm writing a 7 over 3 next to it so I can see it. I think it's helpful for me visually to see it, so my brain's not trying to carry too much of the weight. 24 divided by 3 is 8. 8 times 7 is 56, negative 56. All right, bring it down. 56 minus negative 56 plus 26 is 30. All right, how'd I go back up? I'm multiplying by 7 over 3. All right, again, looks terribly hard. That's divide first. What's 30 divided by 3? That's 10. 10 times, we said that was 7. 10 times 7 is 70. And this was negative. I'm sorry, that was negative. Negative 70. And guess what? We got winner chicken dinner. Now, we could write this as 6x squared minus 24x minus 30. But there is an issue with this. If I just rewrote this, let me go ahead and show you guys this. If I wrote this as x minus 7 over 3, does that look like a polynomial like we normally talk about when I factor it? Now, here's the reason why we're broken with synthetic division. Synthetic division does not see this. It does not see this. It does not see the 3. It sees the fraction. Now, you guys ever eat, that space food stuff or dehydrated food, emergency food, and they say just add water? That's what we need to do. But we need to multiply a 3. I don't want a fraction there. What can I multiply to get rid of that fraction, that 3 as a fraction? What can I multiply to get rid of that 3 as a fraction? I need to multiply by the number 3. So if I multiply this by 3, I want to show you guys on the side here. Please take a look. 3 times x minus 7 over 3. That becomes a 3x. And the fraction cancels out, leaving me a minus 7. So please take a look there. If I could find a 3 somewhere, please, anywhere, somebody throw me a 3. We won't have to write that as a fraction. And guess what? We have a 3 here. 6, 24, and 30. We can factor out a 3. So we have x minus 7 over 3. I'm going to steal a 3 from the synthetic division problem. We have 2x squared minus 8x minus 10. Now at this point, you multiply the 3 to the front. We have 3x minus 7. And then we have our problem 2x squared minus 8x minus 10. If I continue this, before I factor the next problem, if you take a look, there's a 2, 8, and 10 here. We can factor it by a 2. I'm just thinking smarter than harder. I'm going to take out a 2. We are left with 3x minus 7. Left over x squared minus 4x minus 5. Can you guys factor x squared minus 4x minus 5? Two numbers that make up 5 are 1 and 5. Does 1 and 5 subtract out to become 4? Yes, they do. We have x, that's the front, 5 and 1. We said 5 and 1 work. We need more negatives to win. That's why I'm going to give a negative to 5 and a positive to 1. Because a negative times a positive is that negative we needed. Okay, we factor this, our same answer as we got up here. That's the exact same answer. Now, if we have a number in the front, it really takes a toll on us, right? It takes up a lot of work. So we have to be aware of that. Now, let's go ahead and look at another problem. This is going to be a long one. Okay? And the idea is we have these long problems we got to struggle with. Now, on the test, you guys will have less problems, okay? The problems I do give you guys that are going to be a little bit longer, you'll hit the answer pretty quickly. Like, I'll make sure when you guys do the synthetic division that you'll get a hit between like your first like 3-4 guesses, okay? But let's go ahead and start here. Our possibilities for the back are R is making up 20, right? The possibilities are 1 and 20, 2 and 10, 4 and 5, and we're done because we're swinging back around. Now we have to take into the front account. The possibilities for that is 1 over 5, 2 over 5, 4 over 5, 5 over 5, 10 over 5, and 20 over 5. And take a look, some of these repeat. 1, 2, and 4. These all repeat up here. So really, you might say, Mr. Go, there's so much more possibilities. A lot of them repeat. But we also have, just to write it, 1 over 25. That's a possibility, right? 1, 25, and then 5 times 5. So we actually have 3 different fractions we have to look at. You know what? Likely chance of 1 over 25 being a root? 0. Okay, like 0.10, sure. But we have to write it just to make sure that we're good with it. Understand that these are possibilities. And just to emphasize that these repeat, 5 over 25 is just 1/5, right? That's really this guy here. 10 over 25 is really 2/5. And 20 over 25 is really 4/5. So we really only added a couple of extra ones here. Okay. So for this problem, I would go ahead and just go through it. 25, negative 110, negative 79, and 20. The problem with this is it is kind of big numbers. But I'm going to show you that we're either going to hit it or miss it pretty badly. We'll try with 1 first. Okay, so this is where you can practice, or you can just watch me fail a lot. So let's go watch me fail a lot. First one's 25 for you or me. Multiply up, 25. 75 plus 10 is 85, so negative 85. 85, negative 85. Do you think I'm going to get to 20? No, that's like negative 164. That's way too off. Next. Switch. I'm going to erase some of these values. Oh no, I'm almost running out of batteries. Next. Okay, let's try negative 1. So that becomes negative 25. This is negative 135. Do you think I'm going to end up at 20 by my next step? Nope. You suck too. Keep going. We're going to try the number negative 2. Why I chose negative 2? Because the negative is there. I'm too lazy to rewrite it. The factor would have been x plus 2 if you want to write the factor. This would be negative 50. This is going to be negative 260. Oh my goodness. Getting over here would be positive 520. Oh my goodness, way too big. Next. Let's try our positive 2 now. That's a positive 2, 25. That's 50, negative 60, negative 120. Does that look like it's going to get to 20? Next. Let's try 4 then. 4. That's 4 now. That's 100. 10. Okay, negative 10. Negative 40. These are smaller numbers. Ah, man, that's not close. Negative like 119. Nope. Next. Did anyone actually get the number yet? I mean, I know the answer. I'm just seeing if you guys get the answer. Yeah, I know the answer. Let's go. Yeah, sure. Mr. Code knows it. That's right, negative 4. And this is a positive 4 now, right? So that's negative 100. Oh my gosh, it's negative 210. No way, you are not going to get to 20. Next. And here's the thing. This could be a grueling routine, but imagine if you knew some basic programming. You could program a script to do this in a matter of seconds. And the thing is us building these algorithms into our brains actually translates to programming. If you want to become a programmer, these mathematical concepts, these mathematical algorithms actually are super cool when you guys end up starting to write math programs. Let's try 5 and negative 5. Okay, I don't know if this is going to work. Let's try it. 5 becomes 100. This is negative 10. Okay. Oh wait, I messed up. That's not negative 10. That's negative. That's positive 125. 5 times 25 is 125. This becomes positive 35. Okay, 35. Is that right? No, 15. I'm sorry. 15. 15 times 5 is 75. This becomes a negative 4. Wait, what? Wait, negative 4 times 5 is negative 20. Oh my gosh. It worked. It worked. First answer is 5. Now, what we have left is a big mess. We have 25x squared plus 15x minus 4. Now, we have to work our best to be able to factor that by hand. Now, again, the way I draw factoring by hand, I write down all the possibilities out. And that's going to be 1, 25, 5 and 5. We have 1 and 4 and 2 and 2. I don't know which of these are going to work, but they better subtract out to become 15. So let's just try the 5s. 5 times 1 is 5. 5 times 4 is 20. Is 20 minus 5, 15? It is, let me show you guys this again. I took 5 times the 1. That's a 5. So the other 5, my wingman has to cover the other girl. That's 20. 5 and 20 do subtract out to become 15. So now that we know that works, we know our values are going to be 5 and 5. And who'd you multiply the 5 by? It doesn't really matter here because they're both 5. 4 and 1. Who needs to win the positives? So the 4 will be a positive because 4 times 5 is the 20. I need that to be positive. And the negative is going to be that. Okay, so our terms are x minus 5, 5 minus 1, and 5x plus 4. What are the roots? The zeros. What are the zeros? 5. Real quick, if you can't see this in your head, equals 0. You move the 1 over it, divide the 5. That's a positive 1 over 5. That's how fast you should be able to do it, 1 over 5. 5x plus 4 equals 0. Move the 4 over, becomes negative, divide the 5. Negative 4 over 5. These are my roots. Were these possibilities in my list of so many possibilities? 5 was a possibility, 1/5 was a possibility, and negative 4 over 5, that was a possibility too. Okay, let's do the same problem. I'm going to say 25 minus 110 minus 79 and 20. And what happens, I'm going to go ahead and do one more problem here. Same exact problem like you did before. I'm going to take out negative 4 over 25 because I want to show you it works. Okay. So what if I was trying to do negative 4 over 5? Now the factor, because synthetic division is a little stupid, it's x plus 4 over 5. What is the factor we really said it was going to be? It was going to be 5x plus 4. That's the real factor. This is the real factor, but synthetic division is blind to that. So be aware, be careful. So here we go, 25. Multiply this by 4 over 5. So negative 4 over 5. I'm right there in the front. 25 divided by 5 is 5 times 4 is 20, so that's negative 20. think that's right. 5 times 4 is negative 20. We're going to combine those together. This becomes a negative 130. And we're going to multiply this by negative 4 over 5. Now, we have to do long division here. It's fine. 5 goes into 13 2 times, remainder 3. 5 goes into 30 6 times, that's 26. And we're going to multiply 26 by 4. That's 104. So it's going to be 104 here. Okay, positive 104. Subtract those out. That's going to be 21 plus 4 is 25. So positive 25. We're going to multiply this by negative 4 over 5. 5's divide out. Oh, it's the same thing. It's going to be negative 20 again. Oh my goodness, take a look here. Winner, winner, chicken dinner. We did get a 0. Please practice these because you might end up having to divide fractions. And they're not hard. You just got to get used to the pattern. It's actually pretty easy. And it's always this nice and clean number. If it's not nice and clean, it's probably not going to work. Okay, rewriting this, we have 25x squared minus 130x plus 25. Now, we mentioned before that I need to steal what number so I don't have a fraction? What number do you think I need to steal from this? I need to steal a 5 so I don't have a fraction anymore. So we take out the 5 and we're left with 5x squared minus, okay, I don't know what 5 goes into 130, but we can try. We actually wrote it up here as 26. But if you didn't know, 5 goes into 13 2 times, remainder 3. So 5 goes into 36 times, and then plus 5. We have x plus 4 over 5. Now if I multiply the 5 over, we have 5x plus 4, and then we have to factor this by hand now. Lucky for us, we have 5 and 1, 5 and 1. 5 times 5 is 25, and 1 times 1 is 1. They do add up to 26. It turns out this is going to be 5x, x, and 5 in the back, and 1, and minus minus. Guess what? That's our same answer as we got over here. Okay. The next part of this homework is actually going to be easy. So the first part of the homework is the hard part, that polynomial part. The last part is really a key word here, and the new word we're going to hear is multiplicity. Multiplicity means how many times do you see that number occur? How many times does it repeat? Now, let me give you an example. If I write x minus 4 squared, what numbers will make this go to 0? The numbers are 4, right? It doesn't 4 make this go to 4 minus 4 is 0, but it really happens twice. 4 and 4. So what we say is the answer is the 0 is 4 with multiplicity of 2. Again, let me say this again. We have a 0 at 4, but how many times does 4 happen? It happened 2 times. That's it. Why is this important? Because roots sometimes repeat themselves. If I give you x minus 3, x minus 2, and x minus 6 cubed, what are the roots of this problem? The roots are, and let me show you guys in a table here. This is also in the homework. These are my zeros, and these are my multiplicities, M-U-L-T, okay, abbreviated for multiplicity. Tell me some of these zeros here. A 0 would be, isn't a 3 a 0? How many times will 3 be a 0? Only once, because there's no exponent here. It only happens once. What's my next root? 2. Good. How many times does that happen? Only once. What's my next root? Next root is 6. How many times does it happen? Well, this happens 3 times. This is super important because if you look at x, x, and x, those multiply to become x cubed, right? But that's not the answer. This guy actually has 3 x's buried in it. So it's actually 3, 4, 5. So this is actually an x to the 5th problem. And we're expecting at most 5 roots. And in this case, we have 1, 2, 3, 4, 5 roots. If I go backwards, if I give you a problem, let's say we have, here are the zeros. Zeros. And these are multiplicity. Okay, so this part of the homework is actually super easy. We have 1, 2, 3, negative 5. And the multiplicity is 4, 3, 2, 1. So on your homework, this number would be huge. This is x to the 15,000 problem, whatever. But here's what we do. We say our first factor is x minus 1. That's our first zero. Our next one is x minus 2. That's our second zero. Our third zero is x minus 3. And our last zero is actually x plus 5, right? That's my zero, x plus 5. Now, here's the next thing I need to say. How many zeros happened at 1? What was the multiplicity? It happened 4 times, so you got to give me 4 of these. How many zeros happened at 2? 3 of these. How many times did it happen at 3? 2 of these. How many times did it happen at 5? Negative 5? Only once, and I don't need to write the 1 on top. Okay. All right. So on your homework, you'll be writing, filling out tables, working from the tables, writing multiplicities, and going back and forth. And that's probably like the easiest part of this homework. Just FYI, if you do see something like this, x squared times x plus 4 squared, okay, the table would be zeros and multiplicities. What's a zero here? The zero is free. That's a 0, happens 2 times. Negative 4 happens 2 times, okay? All right. The last one is if they tell you the roots, let's tell you the roots. Let's say the roots are 3, 2 with a multiplicity of 4. Okay, a multiplicity of 4. And 5, okay, with a coefficient. No, that's terrible. Coefficient of negative 3, okay? I'm going to tell you guys how to write this original polynomial. The roots are 3, so my factor is x minus 3. My root is 2, my factor is x minus 2. How many times does this happen? 4 times. My root is 5. My factor is x minus 5. And you have to write a coefficient of 3. That means you're going to stick a negative 3 in the front. And that is your polynomial. Okay, so here's the keyword. If it says coefficient, you're going to stick that in the front. That's it. I'm not going to expect you guys to multiply this out. You're not going to have to multiply this all out. You just got to write the factor form and you guys are good to go. Okay. All right. So this is the instructions for homework. If you guys have any questions, you guys can stick around if you have problems with the old homework. But besides that, our synchronous time is over. Thank you very much.